Dragonfly is taking shape. A new exoplanet at Beta Pictoris. Hera gets a software upgrade mid-flight. And new features hiding in the Orion Nebula. And on Space Bites Plus, how we can paint satellites black to reduce their light pollution. All this and more in this week's Space Bites. Okay, it's getting real. It is getting real now. We got some new images from NASA of their construction on the Titan Dragonfly. And of course, this is the most awesome mission that anyone has ever conceived. This is my hill. Bring it. And that is that NASA is sending a nuclear battery powered octocopter to Titan to fly around, take pictures, look at rocks, and just help us understand the conditions on this planet that kind of mimics what the early Earth might have looked like, although it's really cold. It is so cold that methane falls as rain and collects into streams and seas. The mountains, the rocks are made of ice that is so cold. It is rock-like hard. And this is just an incredible world. I can't wait to see it up close. And this is just the best machine. It'll fly around, explore. It's crazy. I think I had been living on just copium and dreams. And now we actually see a picture of the Titan Dragonfly under construction. And this is making the whole thing feel incredibly real. So you're looking at the chassis of the Titan Dragonfly. You can see the landing legs beneath it. You can see the 4-meter long length of the actual helicopter, octocopter probe's body. That's about 13 feet for the Imperial folks. And then you can see where the octocopter propellers are going to be attached. You can even see where the nuclear battery is going to be going. So this is kind of bringing all the pieces together. And the next step is for them to actually assemble all of the different instruments and parts. And so in the next weeks, they're going to be adding flight bulkheads, wiring cables, connectors, and everything that's going to just tie all of its systems together. And then they're going to put in all of the boxes, the instruments, insulation, and then they're going to get to the shake test. This is the shake table that will mimic the conditions of launch. And normally when you send a spacecraft to space, once you've gotten through the launch, the upper atmosphere, then you're in space and the vibrations settle down. But for Titan Dragonfly, you not only have the vibration of the launch, you have the vibration of the entry into Titan's atmosphere, and then just the continued operation of this helicopter flying around in an atmosphere that is 1.5 times as dense as the Earth's atmosphere. And one of the other issues is they had to do a seal test for the body of the helicopter, because most of the time you just need to make sure that you can keep your insides in when you're in space. But in this case, you've actually got this external pressure that is fairly high that's going to be trying to make its way into the interior of Titan Dragonfly. And this is another thing that they have to deal with. This is unique to missions that have ever gone to other worlds. But once they've gone through the integration, once they've gone through the testing, then in 2028, they are going to blast off for Titan. And that is just like 2 years away. I don't know how many sleeps that is. And then in 2034, it will arrive at Titan. And then I will just be glued to the NASA data feeds as we get more information about this incredible world. So if you've ever operated a computer, you know that if there's anything going wrong, you just turn it off and you turn it back on again.
Hello, IT? Have you tried turning it off and on again?
In fact, when my kids were young and they would come to me with technical support problems, I would tell them that I wouldn't help them until they had turned it off and turned it back on again. And most of the time that would fix their problems. Sometimes it wouldn't, but I was able to get in there and hack with the BIOS and fix whatever their problem was. But imagine when you have a computer that is tens of millions of kilometers away on a robotic spacecraft, and that if you try to reboot it, and it doesn't come back, well, that's just too bad. And so this is the challenge that the engineers at the European Space Agency were dealing with their Hera spacecraft. Hera is the follow-on mission to DART. DART was the one that crashed into asteroid Dimorphos, blew out this plume of material. Hera is going to now do follow-on observations at the Dimorphos Didymos system. There was a rush timeline in building the Hera spacecraft. And so the software developers working on the mission didn't have time to fully create all of the code that would be necessary for the asteroid arrival phase. So instead, they got all of the code ready for the launch and the cruise phase, and then they were planning to patch up the spacecraft when it arrived at the asteroid. But this is scary. This is such a scary event. And so they knew that this was a very dangerous event, and so they had to make absolutely sure. There's two parallel processors on the spacecraft itself for redundancy. So if one goes down, the other can pick up. So they have a way to make sure that you only sort of put half of the spacecraft to sleep at a time. They also have a full copy of Hera on Earth. They spent 18 months testing the software across 50 separate ground tests using this spare version of the spacecraft, making sure that it recovered every single time that they rebooted it. And then they sent the code and rebooted the spacecraft, and it is now working with the new updated version, ready to go into its asteroid exploration phase of the mission. And so Hera will arrive in November of this year to begin examining the wreckage left over when DART crashed into Dimorphos. And we've got a story about this on Universe Today that was written by Mark Thompson. One of the most famous exoplanetary systems that astronomers have studied is called Beta Pictoris. And this is a young star system, and we already know of two giant exoplanets in the system. And recently, astronomers were using James Webb to analyze one of the planets, and they accidentally discovered a third planet. And the way they did this is actually really interesting because it suggests an entirely new way to search for exoplanets. So let me explain the system. Beta Pictoris is the star, and it's fairly young, and it has two giant planets that we knew of, Beta Pictoris B and C. In case you've never realized this, whenever astronomers are talking about an exoplanetary system, the star is A. And so Beta Pictoris A is actually the star, and then Beta Pictoris B is the first exoplanet that's ever discovered. Beta Pictoris C is the next exoplanet that's discovered. And the problem is that the position doesn't match the letters. And so you can find new planets that are closer or farther, and they just get added up depending on where you are in that lettering. So it's kind of confusing, but also sort of gives you a sense of what order the planets were discovered. And so astronomers were using James Webb to study the atmosphere of one of the planets in the Beta Pictoris system. And this is the sort of the new capability that James Webb has brought to the table. And it's taught us so much about exoplanets, which have carbon dioxide in their atmosphere, methane in their atmosphere, and even other more strange elements, water vapor. And so the astronomers were staring at this region, and they were expecting this really kind of smooth list of chemicals that were available in the area. And specifically, they were looking at carbon monoxide. And so what they found was a bunch of peaks and troughs in the spectrum, which was not what they were anticipating, which told them that there was something there. But I mean, that could just be the disk of material around the star. But they were able to actually detect the movement of this collection of peaks and troughs of carbon monoxide in the chemical fingerprint. And that told them that whatever this thing is, it's moving. And they were able to then identify that this is actually a planet. And this is new, to look at just a region around a star that you have already discovered exoplanets in using, say, the transit method in the case of Beta Pictoris, where the planets are passing in front of the star. And to then, just by analyzing the chemical fingerprint of regions around the star, to turn up another planet. And so this is Beta Pictoris D. We don't know much about the planet because it wasn't discovered using the regular tried and true methods, but it is probably about twice the mass of Jupiter, which still makes it the smallest of the planets in the system, and it orbits at a distance of 30 astronomical units. So imagine Neptune in our own solar system. And this is the widest orbit of the three planets in the system, but it's still located inside the inner edge of the debris disk that is around this star system. So new planet, but more importantly, new technique for discovering planets. And we have a story about this on Universe Today from Evan Goff. We know that there are stellar mass black holes. That's what you get when a star with more than 20 times the mass of the sun explodes as a supernova. The remnant is a stellar mass black hole. And we know that there are supermassive black holes, those monsters at the hearts of galaxies with millions and even billions of times the mass of the sun. But where are all the in-between ones, the intermediate mass black holes? It's been this weird missing gap between the stellar mass and the supermassive black holes. And astronomers have found a handful, but not as many as you would hope to find out there. But a place they seem to be turning up is inside dwarf galaxies. Well, now astronomers have found another one, and this one's really far away. It's about 3.4 billion light years away from the Earth. And it was located in a dwarf galaxy, and it was only discovered because this extremely powerful jet of radio energy was coming out of this dwarf galaxy. And so much energy that it could be seen billions of light years away. And so astronomers are watching the spot in this dwarf galaxy brighten and brighten and brighten, and they calculated that it must be an intermediate mass black hole that was tearing a star apart. They don't have an exact measurement of the mass of the black hole, but you're looking at more than 100, less than 100,000 times the mass of the sun. And this could explain an entire class of objects that we've reported on in the past. The term that is out there right now is fast evolving blue optical transients, or FBOTs. And I've complained about this in the past, that I really don't like the name FBOT, or having to say all the words. And so we need a short form of the word. And we have a problem because previously it had sort of been thought that maybe these were somehow connected to supernova. And someone in our chat thought a great name would be a bloopernova, which is perfect. I love it. And yet now, oh, are they actually related to intermediate mass black holes instead? So we need to be really careful when we name these things that we don't get stuck with a bad name. Like, I don't know, the Big Bang, black holes, dark matter, dark energy. See the problem? So I guess I'm going to keep calling it FBOTs for a while. Got a story about this from Matt Williams. Every week, we do a vote on our channel where you tell us what you thought was the best space news story of the week. And the winner last week was radiation protection from magnets. So thank you everyone who voted last week. Of course, we will put the vote for this week's poll into the post tab here on our channel. So go ahead, vote, tell us what you think is the best space story of the week. The ancient astronomers were actually very good at their job. They had made precise measurements of all of the stars in the sky. They used these sighting tubes where they would look through and measure the exact position of stars. And in fact, there's a great story about how the ancient Greek astronomers proposed that the Earth might be in orbit around the sun. And the way that they would know was that they would measure the parallax. They would watch as the stars were going back and forth over the course of the 12-month journey of the Earth going around the sun. But they didn't have telescopes, and so they weren't able to measure that back and forth movement. This has nothing to do with the story, but I just love this anecdote. But anyway, and so you have these ancient astronomers that are measuring the sky with incredible precision, and they were tracking what they consider to be the brightest stars in the sky. But in their top 20 lists, both Ptolemy in the 2nd century, Hipparchus and Al-Sufi in 964 said that Theta Eridani was one of the 13 brightest stars in the sky. And it is definitely not one of the 13 brightest stars in the sky today. So like, how could it have changed in brightness so much? We have a few hints. And so in the 1800s, Giuseppe Piazzi identified that it's actually a binary system. So there are two stars orbiting around each other. And more recently, astronomers have figured out that it's actually a triple star system, and that some of the stars are on highly elliptical orbits, which means that they get very close to each other and very far away from each other. And that if you get the mechanics just right, you'll have a time when two of the stars can share an envelope. And this is a situation where the stars are sharing material between them in a way that is much brighter than normally each of the individual stars would be. And so it appears that back 2,000 years ago, and even 1,000 years ago, these three stars were in a configuration where they were having this common envelope and they were causing them to be much, much brighter, and that this might happen again in the future. And in fact, this might be the kind of thing that we can look for out there in the universe. And I love just this confirmation that the ancient astronomers were actually really good at their jobs. They just didn't have that one piece of technology, the telescope. We've got a story about this from Evan Goff. And finally, we've got two stories that really I'm sharing because the picture is so cool. You're looking at a picture of the Orion Nebula, and this is a famous, one of the brightest objects in the night sky. If you've got a small telescope, you've seen Orion. If you're taking pictures of the sky, you've taken pictures of the Orion Nebula. It is hard to miss, and nothing really compares in the sky. And so you'd think that we have it very well studied, but now astronomers have discovered that there are some new, fairly large features in the Orion Nebula. They seem to be these really large bubbles that are expanding outward from the Orion Nebula. And you've got a couple of sources where these bubbles are coming from. And normally when you see bubbles in a star-forming nebula, the answer is supernova. When you have star-forming regions with a lot of really big stars, then those biggest stars go through their stages early on, they use up all their fuel, and then they detonate a supernova. This creates these cavities, these bubbles that then compress gas and dust around them. They can encourage other star formation to happen. And so astronomers have found these large cavities in the Orion Nebula, but they don't match the signature of a supernova explosion. Instead, these seem to be driven by a couple of stars in the nebula. And so you've got this incredibly powerful star that's putting out these very strong winds, and those winds are piling up material in the nebula. And then there's another star that's putting out its winds, and then you actually got interactions and collapse between the winds from those two stars. We've got a story about this from Evan Goff. And now you're looking at a picture of the globular star cluster Omega Centaurus. And this is the largest globular cluster in the sky. And unfortunately, I can't see it from where I live. It's only visible in the southern hemisphere. I've seen it once on a trip to Australia. Some people let me look through their telescope and I could finally see Omega Centaurus. It contains 10 million gravitationally bound stars, and it is as old as the universe itself. And astronomers think there should be about 10,000 stellar mass black holes inside Omega Centaurus, and yet none have ever been found. There is some evidence that there's an intermediate mass black hole, so something with more like hundreds or even thousands of times the mass of the sun. And this has been found by the wake that it's causing on various stars in the region as it's moving around inside this cluster. But now astronomers have found a star that appears to be orbiting around nothing. And so just think, like out of the 10 million stars in this globular cluster, astronomers have found one that appears to be just orbiting around. And of course, that nothing has turned out to be a black hole with 4.46 times the mass of the sun. And they were able to get this perfect measurement by calculating the mass required to make this star move in this tiny little circle. And what's great about this is that they know it's a black hole and not a neutron star because 4.46 solar masses is more than the biggest possible neutron star. And so one down, 9,999 to go. Now, this is just a fraction of all the stories that we're covering on Universe Today. Dozens and dozens of stories. And obviously the right thing to do is just to watch the Universe Today website all day, every day, for the moment a new story is posted. But if you're too busy for that, then why don't you sign up to my weekly email newsletter? I write a description, a synopsis of everything that we covered on Universe Today. I write every word. There's no ads. Go to universetoday.com/newsletter to sign up. I don't know if you've noticed, but on our channel, we don't have any ads. We don't have any sponsorship messages, no mobile games, no VPN networks. And that is the model that we prefer. And in fact, we are fully funded by the patrons who watch our material. And if you want to watch along with them, we actually make another version of every episode that we release on Patreon. It's completely free. There's no ads and there's extra content in those. So you can just go watch it right now. You don't have to sign up. You can just watch it. And this week we've got a story about how Engineers are using Vantablack to paint spacecraft to try and minimize their light pollution. I'll put a link down in the show notes so you can watch that version of this video over on Patreon. How do you do, fellow kids? I've watched two movies that I'm sure many of you have seen, The Backrooms and Obsession, and I'm going to give you my movie review of them. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Brian Bodie, Caradwin, Chuck Hawkins, Commander Baylock, Dark Finga, David Giltonen, David Matz, Enthralling Reading and Math for Toddlers, Evan.Pro, James Clark, Jeremy Mattern, Jim Burke, Marcel Smith, Michael Purcell, NASA Ocean Guy, Nordspace, OneStepForAnimals.org. Please follow my nephew at vbrick6994, Rinkaidu, Richard Williams, Sean Sargent, Stephen Filer Bunley, Team 49, Telescopes Canada, Vlad Chaplin, Wolfgang Klotz, Zelda, It Was Funnier in My Head. First, thanks, Zelda, for giving us so much entertainment. We all really appreciate it. If you look in the comments, people have been mentioning you by name. So that was really fun. And I was glad to, with a straight face, say whatever you were asking me to say. So I watched a couple of movies that I want to give you my report on, which is Backrooms and Obsession. So I'll tackle Obsession first. You know, both these movies have made like $400 million, and they both came from YouTubers, and like those are my people. And so I just want to give just congratulations to the teams that worked on both of those movies. Obsession was great. I really enjoyed it. Very creepy, very horrific, kind of what if you get your wish come true, monkey's paw kind of story. But really, like, the direction and the acting is top notch. You know, I have some thoughts and some notes. Like if I could sort of help them rewrite the script, I would give some additional suggestions. But like just in general, if you want a movie that's going to make you feel really tense, really uncomfortable, and yet you'll be gripped the entire way through, I highly recommend Obsession. Backrooms is next level. Now, I have watched the original Backroom series on YouTube, and so I was kind of familiar with the lore, and I couldn't even understand how they would make a movie based on the Backrooms lore that would both satisfy the needs of the Backrooms audience on YouTube, but also be able to like make a movie that the general populace would enjoy. And they nailed it. Cain Parsons' direction in Backrooms is just perfect. The feelings that you get in watching this movie, the sense of dread, the looking around your shoulder, the confusion, the curiosity for what's around the next corner, all of that just felt perfect. And for a kid this young who is making a movie that's this good, unbelievable. Like, you will just watch this movie and you will just, I think you will enjoy yourself. And, you know, when I watch movies that are weird, and Backrooms is definitely weird, they can be weird and not make sense. And they're weird for weird's sake. But Backrooms is in this very rare class of movies where it's weird, but it also kind of makes sense. And so props to them. And I know it's like a tough thing with writing the script. You know, I'm trying to give any spoilers, but that they had to come up with a script that provided a more sort of cogent explanation for what the Backrooms were, and yet keeping it weird and mysterious. And that was all great. Again, I have notes, but you know, they would sort of go into a spoiler-filled version of my reviews. Bottom line, both Obsession and Backrooms were wonderful. Movies are back, baby. So get out there and watch them and support the creators. And then hopefully more YouTubers are going to get movie deals from this new resurgence. All right, we'll see you next time.